Welcome back to another video. In this video, we're going to talk about how in the world do you find the asymptotes of a rational function. So first of all, let's recall what a rational function is. So hopefully you watched my other video, Introduction to Rational Functions, but if not, I'm going to give you a quick recap. So rational functions are basically a function that's a fraction that has a polynomial in the numerator and a polynomial in the denominator, and the denominator cannot equal 0, right? Rational functions have breaks in their graphs, which we call asymptotes. They have vertical asymptotes and horizontal asymptotes. We talked about those in the last video, Introduction to Rational Functions. However, there's also another asymptote it can have that we did not talk about, and they're called oblique, or also known as slant asymptotes. And basically, it's a break in the graph that goes at an angle or goes along a line. Some kind of diagonal line. And so what we're going to talk about in this video, how do you look at the function in symbolic form, meaning in its equation form, and find the asymptotes? So I want to start with the vertical asymptote. So to find the vertical asymptote is the thing that makes the graph undefined. So what makes the graph undefined? When the denominator equals 0. So in order to find the vertical asymptote, you want to take the denominator, set it equal to 0, and solve for the variable. So really quick example. If you have f of x equal to x 10x plus 3 over x plus 2, then you will take x plus 2, which is the denominator, set it equal to 0, and solve for x. So you will take the denominator, set it equal to 0, solve for x, subtract 2 from both sides, and you will get x is equal to -2. So that would be the equation of your vertical asymptote. So really simple. It could get a little bit more complicated or just involve a little bit more work if the denominator is a polynomial higher than first degree. So you might end up with a quadratic equation or a cubic equation, just depending on what the rational function is. But that's how you find the vertical asymptote. Set the denominator equal to 0, solve for x, and that gives you your equation. All right, so now what about the other asymptotes, the horizontal and the oblique ones? All right, in order to find the horizontal and oblique asymptotes, you have to look at two things. The first thing you gotta look at is the degree of the numerator, which I'm gonna call n in this video, and you also have to look at the degree of the denominator, which is the fraction on the bottom, and I'm gonna call that m in this video. And there could be one of three cases that can happen. So case one is the case where n is less than m. That means the degree of the numerator is less than the degree of the denominator. If that is the case, then you have a horizontal asymptote at y equal to 0. And that's basically the x-axis. So that just means your x-axis is your horizontal asymptote. Alrighty, that's case one. Case two is the case where n equal m. That means the degree of the numerator is the same as the degree of the denominator. If that is the case, then you end up with a horizontal asymptote at y equal a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator, okay? So if that is the case where the degrees are equal, then you'll end up with the horizontal asymptote at y equal a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Now case three is the case where n is bigger than m, but n is bigger than m by only 1, okay? So in this particular case, you will end up with what we call an oblique or a slant asymptote. And the way you find that is that you have to actually go through and divide the denominator or the numerator by the denominator. So you have to do division of the polynomial to figure out what that asymptote is. And the asymptote will be the quotient, and you can just disregard the remainder of that division problem, okay? So let's look at some examples. I'm going to show you an example of each case. So a case 1, a case 2, and a case 3. So let's look at those. First example, we want to find all asymptotes of f of x equal x minus 2 over x squared minus x minus 6. So the first thing we want to do is find the vertical asymptote. So remember, you find the vertical asymptote by taking the denominator and setting it equal to 0 and solving for x. So in this case, our denominator is a quadratic. So we end up with a quadratic equation, which you can solve by any of the methods we've learned so far about solving quadratic equations. This one actually factors really nicely. What are factors of -6 that add to -1? And that would be -3 and +2. -3 times 2 is -6, and -3 plus 2 is -1. And so you take both of those and set them equal to 0. Add 3 to both sides here. You get x is equal to 3. Subtract 2 from both sides here. You get x is equal to -2. So you get two vertical asymptotes, x equal to 3 and x equal to -2. So that's the first asymptote, the vertical asymptote. Okay, so now to find the horizontal or oblique. Now, I didn't say this earlier, but you cannot have both a horizontal and oblique. It's going to be one or the other. Because remember those 3 cases, only one of those cases can happen. You can't have more than one happen at one time. So for those, we need to look at the degree of the numerator. So remember, the degree is the highest exponent of that polynomial. And the highest exponent on x here is 1. So my n, which represents the degree of the numerator, is 1. The degree of the denominator would be 2 because 2 is the biggest exponent. So my m is equal to 2. So in this case, n is less than m. 1 is less than 2. So this would be a case 1. Case 1 said that if that was the case, then you have a horizontal asymptote at y equals 0. So then that would be all of your asymptotes. These are your vertical asymptotes. That's your horizontal asymptote. So voila, that's how you will work that. Let's look at another one, another case. Okay, for this second example, we want to find all of the asymptotes of f of x equal 2x plus 1 over x minus 3. So in this case, if we start off with our horizontal asymptote, we take our denominator, set it equal to 0, and solve for x. And we get x is equal to 3. So we end up with one vertical asymptote, okay? So that one was pretty easy because it was a linear polynomial in the denominator. So solving it is really easy. Now for the second portion, to determine what the horizontal or oblique asymptote is, we have to look at the degree of the numerator, which in this case is 1. Our highest exponent on x is 1. And the degree of the denominator, which I'm calling m, is also 1. So in this case, our n equal our m. So this is a case 2. When there is a case 2, you end up with a horizontal asymptote, and I'm using HA for horizontal asymptote because I don't want to write it all out. But you end up with a horizontal asymptote at y equal a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So the leading coefficient is the coefficient of the variable with the highest exponent. So this is the variable with the highest exponent, so the coefficient is 2. Here's the variable with the highest exponent. The number in front of there is no number, so there's an understood 1 there. So it'll be 2 over 1, which equals to 2. So y equal 2 is your horizontal asymptote. So that would be your asymptote. You have a vertical asymptote at x equal 3 and a horizontal asymptote at y equal 2. Okay, in this last example, we're going to do the same thing. We want to find all of the asymptotes of f of x equal x squared plus 1 over x minus 2. I'm going to start with the vertical asymptote by taking the denominator and setting it equal to 0. Solve for x by adding 2 to both sides. I get x is equal to 2. So that's my vertical asymptote. And now to find the horizontal asymptote, I have to look at the degree of the numerator, which in this case, the highest exponent of the numerator is 2. And the degree of the denominator, which in this case, the highest exponent in the denominator is 1. So in this case, n, which is 2, is bigger than m, which is 1, and it's bigger by exactly 1, okay? So this is case 3, which tells me I have an oblique asymptote. So now how do I find that oblique asymptote? Well, I actually have to go through and divide this out. I have to divide x squared plus 1 by x minus 2. And I'm going to use synthetic division. So with synthetic division, remember your k is the opposite of this number. So my k will be a positive 2. And then my coefficients of the numerator will be 1. I'm missing the x term, so I will have to put a 0 in that spot. And then 1. Alrighty. So if I use synthetic division, drop the 1 down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 5. That last number is my remainder. Since this was a second degree polynomial, the result would be a first degree. This will say 1x plus 2. And then I would say y equals that. And so this would be my oblique asymptote. I have an oblique asymptote at 1x plus 2. And I don't have to write the 1. I could just say at y equal x plus 2. So this is how you find all of your asymptotes, your vertical, horizontal, and oblique asymptotes. If you have any questions, if anything didn't make any sense, please put your comments or questions, put your questions in the comments below. If this video was helpful to you, hit the like button, and thanks for tuning in, and I'll see you in the next video.